Ever wonder why the ocean tastes like a nightmare? Rain is fresh. Rivers are drinkable. So why does the ocean taste like you're licking a salt mine? The answer is so weird it'll make you question everything you know about water. And here's the kicker. If the ocean suddenly became fresh tomorrow, life on Earth would collapse. This is a story about rocks, time, and the universe's slowest chemical experiment. Let's dive into the salty truth. 4 billion years ago, Earth was a hellscape. Volcanoes screamed, asteroids crashed, and from all that chaos, water vapor condensed into the first oceans. And guess what? Those ancient oceans were fresh. Not a single grain of salt. So where did all the salt come from? The answer is literally beneath your feet. Rocks. Every rock on Earth is basically a salt vault waiting to be unlocked. Rain isn't as innocent as it looks. It's slightly acidic because it absorbs carbon dioxide from the air. This creates carbonic acid, nature's weakest but most patient acid. When rain hits rocks, it doesn't just bounce off. It slowly dissolves minerals trapped inside, especially sodium and chloride. And when sodium and chloride hold hands, they become table salt. But here's the trick. These dissolved minerals don't stay in the rain. They flow downhill. Every river on Earth is a mineral delivery service. Rivers pick up dissolved salts from rocks and carry them straight to the ocean. 4 billion tons every single year. But wait, if rivers carry salt, why don't they taste salty? Because the concentration is insanely low, like 1 grain of salt in a swimming pool. Plus, rivers are constantly refreshed by new rain, flushing out minerals before they can pile up. Rivers are like a highway where cars never stop. The ocean is a parking lot where everything piles up forever. The ocean is Earth's ultimate trap. Salt checks in, but it never checks out. Here's what happens. The sun heats the ocean, causing water to evaporate, but salt can't evaporate. So while pure water rises into the sky to form clouds, all the salt stays behind. Over millions of years, this endless cycle has turned the ocean into a giant salt storage tank. If you could extract all the salt from the ocean and spread it across the planet, it would create a layer over 500 feet thick. That's taller than the Statue of Liberty. But here's a plot twist. Not all oceans are equally salty. The Dead Sea is almost 10 times saltier than the average ocean. That's why you float like a pool toy. Meanwhile, the Baltic Sea is way less salty because tons of freshwater rivers dump into it. Salinity depends on evaporation rates, freshwater inflow, and geography. In super hot, dry regions, even some rivers become salty because water evaporates faster than it flows. The Colorado River and several Australian rivers are proof that fresh water isn't always fresh. Now let's play a thought experiment. What if tomorrow some cosmic force turned all ocean water fresh? You'd think, problem solved, infinite drinkable water. But actually, it would be the worst disaster in Earth's history. First, every marine creature would die instantly. Marine animals evolved for salt water. If you drop them in fresh water, their cells absorb too much water and literally explode. Goodbye fish, goodbye whales, goodbye seafood restaurants. Second, global weather would collapse. Salt controls ocean currents. It affects water density, which drives massive circulation systems like the Gulf Stream. Without salt, the Gulf Stream shuts down. Europe freezes. A new ice age begins. Meanwhile, tropical regions get even hotter because ocean heat distribution stops working. Third, toxic algae would explode. Salt helps regulate the growth of microorganisms. Without it, algae blooms would go wild. The ocean would become a giant, toxic green swamp, undrinkable, uninhabitable. So no, removing salt wouldn't save us. It would doom us. But here's the good news. The ocean has a built-in salt control system. Over time, excess salt crystallizes and sinks to the seafloor, forming solid deposits. Marine creatures help too. Animals like clams and coral use salt to build their shells and skeletons. and tectonic activity recycles some salt back into Earth's crust. Thanks to this system, ocean salinity has stayed relatively stable for hundreds of millions of years. About 250 million years ago, before dinosaurs walked the Earth, ocean salinity was much higher. So in a way, today's oceans are actually healthier and more balanced. Here's something wild. Astronauts' tears don't fall in space. They form floating blobs because of zero gravity. And yes, their sweat is technically saltier than ocean water. Interestingly, ancient oceans were even saltier than today. Your blood has about 0.9% salt. The ocean has 3.5%. But that tiny difference is what keeps you alive. Drinking ocean water dehydrates you because your kidneys have to use more water to flush out all that excess salt. Your kidneys basically go into overdrive and fail. Not fun. So why is the ocean salty if rain and rivers aren't? Because the ocean is the endpoint of a multi-billion-year geological cycle. Rain dissolves rocks. Rivers carry the minerals. The ocean collects them forever. And because water evaporates but salt doesn't, the ocean becomes Earth's eternal salt vault. It's not a flaw in the system. It's the system working perfectly. Every grain of salt in the ocean has a story. A rock that was dissolved. A river that carried it. A sun that left it behind. It's a reminder that Earth is still running experiments. Some take billions of years, and we're just lucky enough to be here, floating on a salty marble in the middle of nowhere. So here's my question for you. Would you rather be stranded in the middle of the ocean or lost in a desert? Let me know in the comments. If you enjoyed unraveling the mysteries of our salty planet, don't forget to like this video and subscribe for more mind-bending science. Hit the bell so you never miss an episode. See you next time, space explorers! Imagine standing in a place so hot your shoes feel like they're melting into the sand. The ground is so scorching you could actually cook breakfast on it. But just a few hours later, the same place flips from oven mode to deep freeze. The sand that burned your feet at noon can freeze your water bottle solid by midnight. How can one place be both fire and ice in a single day? In the next video, we're diving into the strange physics of deserts, and once you see it, you'll never think of hot and cold the same way again.